we have beam penetration design. So we're going to take you through one of our specific calculators with the ability for checking the penetrations in the glulam beams. What is interesting is this can, in a lot of cases, cause a lot of problems, especially in the later stage of the design. But you can also use this and try to check what is happening, and if some of the members what you're using can be used with the same depth and width, but just using some of the reinforcement that is also possible to use in this case. So we have the tributary area, we have calculated the loads, we were taking the governing load case from the beam design and factorialized load on the beam, since that's required in this calculator. And we also have information about the penetration locations and the type of penetration that is acting on the beam. So we'll jump back to the app. We'll go to our project level. We'll add a calculator and select beam penetration. So I'll just type in and go with this. So concerning the beam penetration part, we're going to take the same properties as we have on the previous beam calculation. So we'll select the manual input, we'll select the appropriate grade. So in this case, we have 24C. For depth and width, we'll take through 320 times 720 as we have designed. As soon as we enter width and depth, that will be applied on the dynamic imagery. For span, we'll take 8 meters as we have used it. For the number of penetration, so this is the most important part in this case. So we'll select 3 because we have that as a requirement. For each penetration, we now have options of selecting the type, the location, and if reinforcement is used or not. So we're going to select the rectangle for first and third one. For the second, we'll select the circular one. Also, we're going to quickly take back to the presentation and see what are the locations. So we have 100 times 250 millimeters at 1.8 and 6.2. So the first and third one is on that location. So we have 100 times 250 at location is 1.8. I think we'll have this on the middle of the section, so it's 360, and we're going to firstly check all the penetrations without the reinforcement to see if it's possible to go with that. I'm going to same input to have on the on the third penetration, so just double check 1.8 and 6.2. So it's 6.2. We'll have also unreinforced in this case. And for the third one, or in the locationally, it's the second penetration. We have the circular one. We have diameter of 80 millimeters. It's on 3 meters. We're going to keep it a bit higher, and we'll have the unreinforced as well. So we set up the geometry. It automatically will be shown at the dynamic imagery, and we'll go back and see what are the applied loads. So we have 48.6 kilometer total factorized line load, and we're going to put that into the design methodology. So as I mentioned, it's 48.6. So, and we're going to keep the gamma as it is. At the moment, from user, it's required to input the total factorized load. As we implemented the national annex and load combination, this is also something that will pop up as an option in the future updates. For the design methods, it's worth mentioning that this is according to latest draft Eurocode 5, because we, as I mentioned, start implementing the new Eurocode provision, especially where there are clear gaps in the current Eurocode. For the design data, so we have now options and parameters for inputting, especially for this design. So we'll keep the service class 1. We have some of the inputs, especially considering some specifics to the new Eurocode. So you have the educational content, and you can find whether you need to change something, or you can go with the suggested coefficients. For the load duration, we're going to just select the long term and see is this something that we can continue with. So we can see that the tangent is not passing without reinforcement. So we have either option for increasing the section or selecting the reinforcement. Considering that its best situation is to not change the section, we'll select and see what does the reinforcement can help in this case. So we're going to select for the first and third one to change the reinforcement. As soon as we change this, we have the additional input for the screw data. And we're going to select, we have ability for selection of our partners here. So starting with Eurotech, Rotoblas, Siga, Spax, and Simpson Strong Tie products. And with each product, when you select, for instance, if we go with the Eurotech, you have a full the supply chain availability here. And even if you're not familiar with some of the products over here, you can select the educational content and see all the information about the types of screws, screws family, thread type, head type, diameter, length, service classes, and specification, as some of these things are different from supplier to supplier. In this case, we can go with the fully threaded cylindrical head screw, and we can type in some of the diameters here available. So I'll select Constru X 10 times 600. And we can see if this is something that is okay. So also with the output summary, below that you have the table with information about exactly in which penetration you have a failure and what is the utilization number. So we can see with the reinforcement that the first and third one, we have the utilization that is okay, but with the second one, we still have a tension verification for the unreinforced penetration that is failing. So we can either narrow down the diameter, we can try to see with the other parties in the project to maybe move it a bit, or we can try with the reinforcement. So let's try in this case also with the reinforcement and go with this. So we can see that in case of using reinforcement, it can be a big difference for some location of penetration, and even something is in first insight is not possible. We can use it with just appropriate design method and also reinforcement type. So also what is worth noting for in this last part of input, we can change and modify reinforcement data. So you have option for even increasing the number of screw if you have really high forces for on the location of the penetration. You can also modify the positioning of the reinforcement. So you can see that on the section view here. And in these tabs on the right, you can also check in details about all the intermediate steps of the design. And if you want to go into detail and check what is failing and what you can do to improve your design. So also considering the action, so you have information about the action forces, bending moments on the location of each penetration. You have the geometric limitations, so according to the geometry and the position of the penetration we use, verification for the flexural, shear, reinforcement geometry, and the reinforcement design at the end. So that being said, we know that we can keep up the section we have, and we're going to click Save and go further.